So with all that behind us, we're going to see exceptions in our implementations for stacks and queues. But first, let's do a quick review. We've done this before, but let's talk about abstract data types again. What is abstraction? It's using only the essential elements to describe a system and passing off any of the more detailed stuff to a lower level system. And this is the opposite of our concrete data structure, which is a very low level data structure that is implemented literally as it's defined. So an array is literally as we design it, right? A contiguous block of indexable memory. A linked list is literally a series of linked nodes that refer to each other. When we get to a tree, you'll see that a tree is literally a hierarchical series of nodes linked to each other. And when we define our abstract data types, we need to define what the interface is, what the data stored within the data structure is. And for us, that's generally going to be arbitrary data. We can store whatever we want. Some data structures will have specific types. Some languages will have specific types. We're not concerned about that. And any error conditions associated with any operations. And for us, these error conditions will typically be represented as our exceptions, but they don't have to be. Okay. So the trick is determining what are the essential elements. What are the aspects that can be handed off to another system? And typically, when we're determining what are the essential elements, what we're designing is new behaviors that are on top of the lower level elements. But keep in mind, too abstract means that we're missing key functionality, and too detailed means that we're doubling down on our work. So we bring up this image again. And remember, if this is our target here, if we go too abstract, we're missing information that we need. If we go too detailed, right, we're doing a bunch of unnecessary work that doesn't help us. If this is the goal, going too far in either direction is going to make our work either pointless, redundant, or both. So, abstract data types are implemented on top of another data structure. This is the thing that we are going to push off additional details to, just like we did with a dynamic array. When we implemented a dynamic array, we said, hey, here's the interface that we're going to implement, including things like append, which are not part of the underlying static array. But the storage of the raw information gets pushed off to that static array. So we can implement our abstract data type on top of a concrete data structure, and we'll see that in stacks and queues. We'll also see that it can be implemented on top of an abstract data type. Stacks and queues can be implemented with a dynamic array, which is an abstract data structure implemented on top of a stack. So we don't have to have things that are just abstraction on top of concrete. We can have abstraction on top of abstraction. The key is somewhere at the bottom, right? We've got to get to a concrete basement. We've got to get to a foundation that is concrete. We can't have abstraction all the way down.